So, what if every single piece of software we use, from the apps on your phone to the huge systems that run the cloud, what if it all had an energy bill? Well, today we're digging into a really groundbreaking invention that does exactly that. It literally puts a price tag on code.
I mean, it's a weird question, right? We all know what our refrigerator costs to run, more or less. But what about the apps you use every day? For most of us, that's a cost that's never even crossed our mind.
And that right there gets to the very heart of the problem. Our entire digital world, I'm talking about massive data centers all the way down to the phone in your pocket, it all runs on a staggering amount of electricity. But here's the thing, that energy use is almost completely invisible, not just to you and me, but a lot of the time even to the developers who are actually writing the code.
So, this brings us to what we're calling software's hidden energy bill. It's this cost that's just baked into every single click, every stream, every transaction we make online. And for decades, it's been a cost we haven't been able to measure, much less manage. That is, until now.
I mean, just think about it for a second. We have these energy labels on everything, our fridges, our washing machines, even light bulbs, and they help us make smart choices, right? But for the code that runs our entire global economy and our social lives, nothing. We've been flying completely blind.
Okay, so let's talk about the solution. What if we could create an energy label for code? What if we could finally make all that invisible energy consumption totally visible, just like we do for stuff in our homes?
This quote from the invention disclosure itself really captures the whole idea perfectly. The goal here is to stop treating software like it's some abstract magical thing and start treating it like a physical asset. Like a machine whose energy use you can actually measure, manage, and then of course optimize.
Just imagine for a minute, what if developers could see the energy impact of their code as they're writing it in real time? Or what if companies could choose software not just based on its features, but on its environmental footprint? That's exactly the future this system is aiming to build. Okay, but how does this all actually work? I mean, how do you even begin to calculate an energy score for a piece of code? Well, it turns out it all comes down to a really clever combination of three key ingredients. All right, first up is activity, and this one is pretty straightforward. It's really just asking, how often is this piece of code being used? Is it a function that runs, say, once a day, or is it something that's getting called millions of times a minute? It's simple, right? The more it runs, the more energy it's going to use. Second, we have intensity. Now this measures how much hardware the function is actually using while it's running. Is it just a simple little calculation, or is it a heavy-duty process that's maxing out the CPU and the GPU? This is basically the raw power draw for every single operation.
And the third ingredient is, honestly, maybe the most clever part, structural weight. This adds some absolutely crucial context. It asks, how important is this function to the whole system? Is it some minor feature off in a corner, or is it a core component that everything else relies on? Because, you see, a power-hungry function that's also mission-critical, well, that's a huge red flag. So you take those three factors, activity, intensity, and that all-important structural weight, you multiply them together, and you get a single, really meaningful number. It's a comprehensive, weighted energy metric that truly captures the function's total energy impact.
Now, from that calculation, the system spits out two really key metrics. First, you've got the energy index. That just tells you the raw energy cost. But the second one, the efficiency score, that's where things get really powerful. It actually measures the business value, things like transactions processed or revenue generated, and compares it to the energy cost. So, and this is the key takeaway, it's not just about using less energy, it's about getting the most value out of the energy you're spending. Okay, so we have the scores, now what? Well, this system isn't just about measuring stuff. It's about putting that data to work. Let's take a look at how these scores actually drive real change. What this system does is create this continuous feedback loop. First, it's constantly measuring and calculating these scores. Then, it catalogs them all in one central place for analysis. Next, a governance system can use that data to make decisions, like automatically flagging inefficient code for a developer to review. And finally, all that data drives optimization, which creates this amazing virtuous cycle of constant improvement. And the impact of this is, well, it's huge. This isn't just some theoretical model. It's a practical tool that's designed to plug right into the workflows developers are already using. It gives companies the hard data they need for sustainability reporting and, for the very first time, it directly connects the nitty-gritty technical details of code to real-world business value and actual energy costs. So what does all of this mean for the future?
By finally putting a measurable cost on digital inefficiency, this system is really pointing the way toward building software that is fundamentally greener from the ground up.
And the real-world applications here are just incredibly powerful. Think about it. Dashboards that show developers a real-time energy score for their code, or cloud platforms that can automatically move workloads to the most energy-efficient servers. This is the kind of concrete data you need for serious environmental, social, and governance, that's ESG, tracking.
Ultimately, it all comes back to creating that virtuous cycle we talked about. By making energy use visible, you kickstart a process of continuous improvement. And the result? It's software that's not just more powerful, but also fundamentally more sustainable.
And that leaves us with one final thought to chew on. If every single function, every line of code, actually came with a clear energy price tag attached, just how would that change the way we design, build, and run the digital world of tomorrow? It's a really powerful question to think about.